Okay, so we've got a nice little result about cosets. Let's just suppose I've got two cosets, C1 and C2, both cosets. I'm going to wonder, can these overlap? Maybe, if I've got my set G here, maybe I can get this. There's coset 1 and there's coset 2, and they've got some kind of intersection here. Well, the answer to that is no, they can't. I'm going to assert, in fact I'm going to prove, that C1 and C2 are either equal, in which case C1 equals C2, or disjoint. And disjoint basically means that C1 intersects C2 is the empty set phi. So this diagram I've drawn here just can't occur. C1 and C2 are either the same thing, C1 and C2 overlap like that in terms of a sort of Venn diagram, or they're completely disjoint and they've got no overlap at all. There's C1, there's C2. Okay, so how am I going to prove that? So let's just have a look at this. Let's just say, suppose they are not disjoint. Okay, so what I'm going to say is, if they're not disjoint, I'm going to show that they're equal, and therefore if they are disjoint, they're disjoint. They're either disjoint or equal, basically. So they are not disjoint, and this means that there exists an element A, let's say, such that A is in C1 and also A is a member of C2. So what that tells me there is that C1 equals AH by the previous screencast where I proved that, and C2 equals AH, QED. So what this shows us is that here's my group G, or the set G. The cosets are sort of like this. They don't overlap at all. There's no overlapping here. Okay, and that's quite nice. So they don't overlap. So if I get any element, it's in one and only one coset. Okay, can't be in two cosets, because if it is in two cosets, those two cosets are not disjoint. And if they're not disjoint, they're equal by this. So that's quite nice, and I'm going to stop there.